Assalamualaikum. My name is Muhammad Zafarul Hasnizal bin Zaluhi, and today, for introduction, Malaysia has an equatorial climate with constant high temperature and high relative humidity. So there are two basic types of rainfall causing flooding. First is moderate intensity for long duration rainfall covering a wide area. Second is intensity. High intensity is a short duration locals rainfall. So as practice is probably sufficient for area with minimal or no stormwater issues, but it is generally inappropriate for such as a simple method to evaluate drainage in more complex situations such as tidal influence areas, flood-prone areas, or even in existing development where backwater effect and overland flood flow are often associated. For problem statement, the Parit Raja areas experience flash flooding every year. Recently, the development of district of Batu Pahat has caused the increasing number of inhabitants. So even in the area of Parit Raja, the population has grown more than other areas since UTHM has developed, which has been established as a big university. So this condition happened because of poor drainage system around the campus. Thus, this research is then carried out to find out the best way to overcome the poor drainage system where the drill were and it used to generate the source of water can be part of the drainage system during the wet season to mitigate the flood. We have found the four problem statements. First is topsoil surface. A study on infiltration and particle size distribution has been done in most areas in UTHM campus. It was found that the rate of infiltration is in the range of 0.004 to 0.007 millimeters, and the soil classification based on particle size is between silt to fine sand. The second one is flood. More than 70% of the areas were flooded and it caused damage to property, business or road. The rainfall intensity was too high, where 170 and 247 millimeters per day were recorded at Bangkok Dam and 181 and 229 millimeters per day recorded at Semarang Dam. So the third one, water level. A prior record for an existing well and borehole indicates that the water level available in around 1 to 2 meters under mean sea level. So it means that the layer under the ground had a high level water table. So the last one is subsurface condition. The research area in figures selected by flooding problem and existing well was shown by resistivity survey near research UTHM. The procedure section of line survey was top the wells. The layer of the top covered up to 30 meters of the subsurface and hard rock of the layer. The objective for our project is first to propose a method of flood mitigation for the problem area. Second, to investigate the cause of the flood in the marked area. And the third one, to explore flood mitigation knowledge in disaster management. And the last one, to propose recommendation for local level participation in flooding policy.
Okay, Assalamualaikum and good morning. My name is Muhammad Nazrin bin Mustafa, and today I will present about chapter 2. For chapter 2 is to study is to study the potential of artificial rechange, the water supply to a surface infiltration or injection well recharge system. It is evaluated the quantity of municipal stormwater runoff by the supporting drainage system may be suitable for groundwater rechange. Its potential use will be extremely site-specific and a general evaluation is not useful. And the stormwater drainage design manually is required to be used by authority for drainage design in Malaysia is the Urban Stormwater Management Manual for Malaysia in short form MSMA. Okay, in the picture of left side, as we can see, this is our set area that we have been choose, and for the channel is open channel with rectangular shape, and the condition of the channel is with short grass and muddy. And I have been calculate the manning value. So I have got the roughness coefficient, which means is n. For manning value is 0.022 and to 0.033. Okay, as we can see, this is our site groundwater level. Okay, from the data that has been observed, the length of the channel is 410 meter. At point A, the ground level is 10 meter, while at point B is 8 meter. So we assume the average depth channel is 1.5 meter. And the direction of flow is from point A to point B, with slope 0.00427.
Assalamualaikum. My name is Muhammad Zuhairi bin Muhammad Yusof and I will present about channel peak flow. For the channel peak flow calculation is made by using reference from MSMA in chapter 2, which is quantity design fundamental. The area is divided into three subcatchment, which is subcatchment A, B, and C. And each subcatchment we will calculate its runoff coefficient, which is C, and A, the area of the subcatchment. The sum of runoff coefficient and area of the subcatchment will be summed up and then will be times with rainfall intensity, which is I, and then divided by 360. The channel peak flow in the Taman University area is 7.97 meter cube per second. And then for drainage purpose, for the calculation of drainage purpose, it will be made by referencing MSMA in chapter 14, which is drain and swales. The first step is find the drainage depth, which is D equal to 2.5 meter using try and error method. And then find the velocity of the drainage channel, and the velocity is V equal to 2.4 meter per second. When the velocity is more than 2, 1.2 meter rail needed as safety precaution. As shown in here is the drainage purpose dimension, which we can see the depth of the drainage, which is 2.5 meter, the width 1.5 meter, and the handrail 1.2 meter.
I will explain about attenuation point for flood mitigation method. The primary function of this flood mitigation is to minimize the economic damage and also decrease the flood impact on human life as well as infrastructure. A number of methods have been utilized to accomplish the goal, which include activating early warning system to keep the public as well as federal government agency alert of rising water level and numerous weather conditions. Kaki, Shafi'i, and Khalid 2016 likewise state that doing a measurement in such a location is not a really reliable system and its effect on flood preparedness. An iteration pond is a solution with multiple benefits, from managing excess runoff from agricultural land to saving rainfall for irrigation purpose. An action pond is planned to increase water retention capacity. Attenuation ponds are pond or pool made with added storage space capacity to attenuate surface runoff throughout rainy occasion. They include a permanent pond area with landscape band and surrounding to supply extra storage capacity. They are created by using existing natural land, by excavating a new land, or by building embankment. Existing natural water body must not be used as a result of the danger that pollution, even and poor water quality could disrupt the natural ecology of the system. Attenuation pond can supply both stormwater attenuation and water quality treatment by offering additional storage capacity to preserve runoff and release this at a controlled rate. Attenuation ponds are a vital flood prevention method. As such, they should be cleaned and maintained regularly to ensure they remain in optimal condition. Attenuation pond characteristic. A pond must consist of the following reason. Firstly, a sediment for bay or various other forms of upstream pre-treatment system. Then, a permanent pool which will certainly remain wet through the year or also is the main treatment area. After that, a temporary storage volume for flood attenuation created through landscape bank to the permanent pool. Lastly, a shallow area or aquatic base, which is a shallow area along the edge of the pool to support wetland planting, providing ecology, amenity, as well as safety benefit. Additional pond design functions should consist of an emergency spillway for secure overflow when storage capacity is surpassed, maintenance accessibility, a safety badge, as well as appropriate landscaping. Advantage and disadvantage of attention pond. For the advantage, firstly, can cater for all storm. Secondly, good removal capability of urban pollutant. Thirdly, can be used where groundwater is vulnerable if land. Fourth, good community acceptability. Lastly, high potential ecological, aesthetic, and amenity benefit. For the advantage, no reduction in runoff volume. Then, anaerobic condition can occur without regular inflow. Thirdly, land take may limit use in high density site. Fourth, may not be suitable for steep site due to requirement for high embankment. And lastly, colonization by invasive species could increase maintenance.
For conclusion, flash flood frequently happen at Taman University Paraja. Numerous factors, including the drainage system and surface condition, contributed to the flash flood. The suggestion to upgrade the drainage has been made in effort to address the issue. The catchment area peak flow, the size of the drainage system, and the kind of drainage are a few factors that must be considered for the new drainage project. MSMA contain all the information required for new drainage purposes. The MSMA contain the design manual required for Malaysian drainage system. According to the data that has been analyzed, the intended drainage is 1.5 meter broad and 2.5 meter deep, and the peak flow is 7.97 meter cube per second. To solve the flash flooding problem, an attenuation pond also need to be built as a flood mitigation method. In conclusion, a good drainage system is required to ensure that water can be drained effectively during rain and that there is no overflow of water from the drain in order to prevent flash flood. Additionally, a mitigation pond is required to provide the efficient drainage of a lot water from the drainage following a particular severe downpour. Thank you.